Consider a simple 2D graph. You can draw a straight line on this graph with this equation. Here, beta 0 is the y-intercept. By changing this value, we can move the line up or down as it represents the point at which the line crosses the y-axis. The second value, beta 1, is the slope of the line. By changing this value, we can rotate the line. By adjusting both these values, we can draw any straight line on this 2D graph. Our main goal is to draw the line that best fits the data points. By best fit, we mean minimizing the total error between the y values of the data points and the line. These distances can be calculated as either the mean of sum of absolute distances or the mean of sum of squared distances. Here, we will use the sum of squared distances. But how do we find the values of beta 0 and beta 1 where the line has the least distance from the points? Initially, we assign random values to both beta 0 and beta 1. For simplicity, let's assume both are initialized to -1 and 1. The dataset we have looks something like this, where the x values are inputs and y values are outputs. Let's take only the first values to start. For a given x, we check the error by calculating the squared difference between the y value of the data point and the y value on the line for the given x input value. Now, to minimize the error, both these values should be the same. Since the y value is a label from the dataset, it cannot be changed. The second value is generated using the equation of the line. This equation consists of three components. One is the input x, which is also a data input and cannot be changed. The other two components are our parameters, so we have to change them to modify the output and make it similar to the actual y value. But now the problem is, how do we change these values to reduce the error? We need to determine whether we should increase or decrease these values and by how much. For this task, we calculate the derivative of the output with respect to each of these values. This was a simple equation to get the y value, and we calculated the loss using this y value. So we replace the y value with the equation and get a complete new equation. Here are the derivatives for each of these values. Now, if the derivative is negative, increasing the value of beta will decrease the loss. Conversely, if the derivative is positive, we need to decrease the value of beta to reduce the loss. We will further discuss why we decrease or increase the values by small amounts. Now, for all the points in the dataset, we calculate the mean of all the errors and try to minimize the total error. Finally, we get the resulting line after some updates to beta 0 and beta 1 over many iterations using this derivative technique. This process is known as backpropagation.